everyone, I am Dhiraj Tatar, a system professor in the Chemical Engineering Department of LGIT Ahmedabad. In this lecture, I am going to start new topic of the computer aided process synthesis. So let's start. Chapter name is the design process and topic is gas liquid separator. This is the application of SPNIC software. So in this lecture, I will briefly introduce you how to use SPNIC software. But before that, you should know role of computers in industries. So you can see on the screen role of computers. In this slide, we will see some important points related to the role of computers in automated system of the industries. So you can see first point, why many industries are using computers. We know that by using computers, we can minimize the operating cost, or I can say overall cost of the plant. So this is nothing but first point. I am reading this first point now. You can see on the screen. Computers can help the lower the production cost as they eliminate much of the human labor that must be paid in a traditional factory. Means by using computers, by using automated system, we can minimize the labor cost, we can minimize the overall production cost. Next point is computers also have increased productivity because the entire system is automated and runs smoothly with less risk of the errors. It means by using computers, we can minimize the errors that can occur during the operations. That's why production also increases by using computers. That is the meaning of this second point. That is nothing but computers also have increased the productivity, and I can say that minimizes the errors which can occur during the operations. Now we will see how to simulate gas liquid separator in SPNIC software. But before that, you should know some important points related to the SPNICs. So we will see those important points in the next slide. After that, I will tell you how to simulate gas liquid simulator in SPNICs. So you can see on the screen, this is the first point related to the SPNICs. That is nothing but SPNICs or simply ICs is a chemical process simulator used to mathematically model chemical processes from unit operations to full chemical plant and refineries. Means if you want to simulate any chemical plant, you should have process flow diagram for that process. Then and then you can simulate that process in this software. Otherwise, you cannot simulate that process in this SPNICs. After that, next point related to the SPNICs is HYSYS is able to perform many of the core calculations of chemical engineering, including those concerned with mass transfer, or I can say mass balances, energy balances, vapor liquid equilibrium. That is nothing but VLE data, or heat transfer, mass transfer, or any chemical kinetics, or I can say fractionation and pressure drop. So all these calculations can be possible on this SPNIC software. So by using this SPNICs, we can do major applications which involve in chemical processes. Now we will see how to simulate gas liquid separator in SPNICs. Now in this lecture, we are going to simulate gas liquid separator. So this is nothing but SPNIC software. You can see on the screen. On this screen, we are having simulation environment, or I can say we are having on the left hand side, there is the component list, means whatever the component we are going to select here, those components are going to appear on this list here. But before that, from this list, you can see on the right hand side, we are going to select required component. For example, there is two components in the system, that is nothing but ethanol and Cl2. So from the search option, just select ethanol, put here ethanol, and after that click enter button. After that you will get here ethanol, and after adding this button, means click over this add button. After adding this ethanol component will be appear on this side, that is nothing but component list site. Now we are going to add another component, that is Cl2, chlorine. After selecting this component, click over the add button and you will get this Cl2 on the right hand side. After that, now we are going to select here fluid package. What is the meaning of fluid package? Fluid package is nothing but this is thermodynamic model, and this thermodynamic model is required to carry out any simulation, means to carry out the simulation process, or to carry out the automation, or to carry out the automation process of any processing plant. There is a requirement of thermodynamic model, that is nothing but fluid package in various softwares. So in this thing we are going to select PRSV simulation. So in this example, we are going to select one fluid package, that is nothing but PRSV. That is also given by Peng Robinson. So you can see here, just click on the fluid package. After clicking over this fluid package, you are going to click on this add button. Click over this add button. After adding this button, you will get list of various fluid packages. So you can see there is various fluid packages are available. From this list, we are going to select Peng Robinson SV. That is nothing but PRSV model. That is required for ethanol system. We are having it here ethanol and chlorine system. That's why we have selected here PRSV. Okay. After that, you need to click over this simulation tab now. After clicking the simulation tab, you will get like this. Just click over the simulation tab and just wait for a few seconds. After that, there will be open another tab that is nothing but simulation environment, where we are going to draw our process flowchart. Okay, this is nothing but simulation environment, and in this environment, we are going to draw our process flowchart. And we are going to draw here separator. So that's why from this palette you can see on this right hand side there are various unit operations are available, and from this unit operations I have selected here this first operation, that is nothing but separator. After that, selecting that separator, you need to double click over that separator. After double clicking over that separator, you will get like this. You will get this screen. Okay, now you have to give the names to the various streams. First stream is nothing but your feed, so just give this nothing but feed name. After that, vapor outlet, give this outlet 1. You can give any name to these outlet streams. Okay, you can give any name to these streams, means inlet stream and outlet stream. I have given here feed to the inlet stream and outlet stream, outlet 1, outlet 2. You can just give here vapor 1, or I can say just vapor stream, or you can write here liquid stream like this. Okay, that is depend on you. Whatever name you can give this stream. Okay, so I have given here outlet 1 and outlet 2. After that, now you have to just see here this problem is not solved because we have to provide inlet conditions. Best thing about this software, we need to give here, or we need to provide here inlet conditions, outlet conditions of the outlet stream, that is outlet 1 and outlet 2, calculated by this software. Okay, but feed stream means whatever the temperature, pressure and molar flow rate, means whatever the required things for the feed stream, that is you have to provide. Okay, then and then that will be calculated for the outlet streams. Otherwise this software cannot calculate the various things, that is conditions or properties or composition for outlet stream. Okay, means you need to provide inlet conditions or inlet compositions for this feed. Okay, so you can see here now I am going to provide here temperature and pressure, means whatever the required things for this feed stream we are going to provide now. So I just randomly provided here 25 degrees Celsius, that is feed temperature, and pressure is nothing but we have provided here 1 atm, that is nothing but 101.3249 kilopascal. You can see beauty of the software. Whatever you have selected here, means I just put here 1 atm, and whatever the kilopascal thing, that is calculated by the software automatically. Why this is calculated by this software automatically? Because we have selected here fluid package. Whatever the things are automatically generated here, means automatically calculated here, all these things are calculated because of the fluid package, that is nothing but Peng Robinson SV. Okay, so you can see here there is outlet stream now, means you can see outlet temperature is 25. We have not provided this, but this software is now calculating all these things now. So after providing this temperature and pressure, you can see now on the screen. You can see now. So outlet streams, temperature for this outlet stream and pressure for this outlet stream automatically taken by the software. Now you have to provide here mass flow rate. So you can see here mass flow rate. So just put on the click on the composition button. After that you will get like this. Means you have to provide the feed conditions now. Feed conditions for ethanol and Cl2. Outlet conditions automatically created. There is no need to provide outlet streams, but you have to provide their inlet streams, that is nothing but feed. Means whenever you can just see here, whenever you are providing these feed compositions for this ethanol and Cl2, means I am providing here ethanol 0.5 and Cl2, that is nothing but, you can see on the screen, I am providing that value is 0.5. That is also randomly I have provided here, and that is equimolar composition. That's why moles of this ethanol and Cl2 is equal. After that, just click OK button. After clicking this OK button, you will get like this. Means automatically outlet stream compositions for this ethanol and Cl2 is generated here. You can see.
I have not just means I have not provided outlet stream compositions and conditions here. Means I have provided only feed conditions, only feed compositions, outlet compositions, outlet 1 and outlet 2, that is automatically generated by the software. So what is the meaning of this green line? Green line means you are correct. Okay, means whatever you have done in this software, all these things are correct. After that, whenever there is a red line, means you have made some mistake. Whenever there is yellow line, means some data is missing. You have to provide some data. Okay, so these three indications are very important. You have to keep this mind. Now after that, you can see, just close this tab. After that, you will get like this. So this is nothing but separator. After double clicking over this separator, we have provided all the conditions or compositions for this feed stream. After providing all those conditions and compositions, you are getting the outlet stream composition, outlet stream temperature. Okay, is outlet 1, outlet 2. For these streams, you are getting conditions and compositions from the software. You need to provide condition and composition for this feed stream only. If you want to check whatever you have done in this software, just double click over this separator. After double clicking over this separator, you will get again all those conditions, means you will get again that worksheet. So you can just see here now. So this is nothing but simulation of gas liquid separator. So gas liquid separator means we have provided here two components, that is nothing but ethanol and Cl2, and we have separated those ethanol and Cl2 by using this separator. If you want to check the composition or properties or any worksheet for those outlet stream, you have to just double click over those stream. Means whatever the stream is there, just double click over that stream, you will get required data for that stream. So I'm going to double click over this outlet 1 stream. You can just see here, I will get like this table. So I'm going to click here on the composition tab. You can see here, after clicking over the composition tab, you will get like this. Means these are the composition mole fraction of the outlet 1 stream. Okay. After that, I'm going to click over the outlet 2 stream. So you can see here, after clicking over this outlet 2 stream, you will get like this. So you can see here, this is nothing but composition of the outlet 2 stream. So in this manner, you can check the whatever the conditions, whatever the properties, composition of the outlet stream or any stream involved in this flowchart. Means after clicking over this K values, you are able to watch those K values. After clicking over these conditions, you are able to watch conditions for the inlet stream and outlet streams. So this is all about this outlet 1 and outlet 2 streams. So what we have seen in this simulation, I told you how to simulate gas liquid separator in the SP analysis. So this is nothing but automation system, and in major application of this SP analysis is nothing but means SP analysis. In generally, SP analysis being used in the petroleum industries. So what are the steps involved in this SP analysis? Just listen carefully now. I have just opened this software. After that, we have added the required components. Okay, after double clicking over those components, I will get the list for those components. After that, I have selected here fluid package. That is the heart of this automation. Means fluid package. If fluid package is there, then you can add the various components, or you can able to solve those problems in the software. After that, I have selected here PRSV fluid package. Okay. After that, I have just selected here. After that, I have selected here whatever the separator is required from this tab, and after that, double clicking over this various stream, I have just put the required condition and required composition for the feed, and automatically generated data is nothing but for the outlet streams, that is outlet 1 and outlet 2. If you want to watch whatever the outlet data, you need to just double click over the outlet 1 and outlet 2 stream. And if you want to watch the data for this whole separator, you need to just double click over this separator. You will get required data for this. So this is all about the gas liquid separator.
So this is all about this lecture. We will see next topic in the next lecture. Thank you very much.